welcome back guys to a new video. In last video, as you know, we have learned about the simple methods and I have introduced you about integers. Yes. So simple is that in this video, we are going to learn about the advanced methods of integers. Yes. The advanced methods. We are going to deep diving in the advanced topics of integers. Okay, so let's start the video without wasting any time. First of all, in this video, I have also created this file. So, we are going to understand these uh, binary things at last. They are easy, not to worry about that. We are going to learn them at last. So, this one's at the last. First of all, these float methods. Okay, so we can ask Python, tell me, is that integer, if we convert that float number to an integer, then will the both numbers be the same? So as you can see, 5.5 equals to 5 in Python. So we can write 5.5 dot is integer. We can ask, is it is an integer? Means if we convert it is integer, then will these both value be the same? When we say yes, this both value will be the same, but this won't. Okay, after that there is float um, as integer ratio. Means it convert the float into numerator and denominator. In Python you can't write these things like this 3 by 7. So for easiness it gave this as tuple. Okay, so because 1 by 4 equals to 0.25 and we gave 0.25. Okay, after that let let me check. I have one thing. Okay, if we write um 3.14 only 3.14, then what it gave. Don't get confused. See how much big value is. So nice. So if we divide these two, we will get 3.14. Means when we are just taking the um, pi value, we are just as 3.14 and multiplying it, we are multiplying these high numbers. I also don't know. If you also don't know, just comment down below. Okay. After that, there is from hexa, float dot from hexa and float dot from hexa. These are both of from float. I mean, float dot hexa converts float to hexadecimal number, and from hexa convert hexadecimal number to from float. After that, the floating point. This is an issue. This is the issue of like computer. This is the issue of computer. Computer, you know, guys, computer thinks in like binary things. So if we and binary is what, as the power of 2. So our computer can see 1.1 by 2, 1 by 4, 1 by 8, 1 by 16, 1 by 32, 1 by 64, this much and many more. Okay, just don't follow that. So the thing is that we can't say it 0.3. Let's look at 0.3. It can't. We can't do it 1 by 10. Computer will get confused because of this binary things. So you can see there's an example zero point 0.1 plus zero point 0.2. It should be zero point 0.3, but it doesn't. Okay. So what's the solution of this? By importing decimal module. What is module? Okay, decimal. Okay, what is module? So this is a high level thing, but you keep the module as like this. Someone creates functions. No, you don't know it now. After the that types operations we complete, then just going to take you to the operations. I mean functions, not the operations. Okay, sorry. Okay, so this is a module, means it is like Python only. You assume that, and we connect to someone created this for us. We connected it and it uh, gave some functions like print. It's from vanilla Python, but see, normal decimal. This is the decimal module. So it creates like acts like a real decimal number. Be like, okay, and modules are like our type of peoples create the modules, means functions in Python that helps us for the other things. If you are not new, you should get it. And after that, there's one more common thing: equally trap. These both are same, both are equal, but their type isn't equal. You can see, uh, we run this tells that is the type is equal, and this tells is the value is equal. Okay, but this type isn't equal, so it will take tells false. You can see, if we write float, then in then it will be infinity rather than any number. Let's see, if we compare infinity and infinity both, then what will happen? Let's see. So I will write to print float float, then in inf, I think, yes. Then I will just add a compare sign. Then I will write this same float inf. Let me check. Do inf is that thing where I am? Yes, it's inf. So now if I run, what will happen? Oh, is not defined. Do you mean int? No. Um. Okay. Okay. I got it. Now it's good. False. Oh. Then I will check this thing. False. Let are both the equal? True. Nice. And it's said one more thing, that if we do NaN, then it won't equal to that NaN only. Let's try this thing also. Equals to false. Okay, it is not equals to. Greater than. Sorry, my mistake. Greater than. False. Okay. Um, now, no, nothing is happening. False. So it was true. Okay. So the NaN means nothing is not equals to nothing. Okay, and like it say, if we minus these, then we got NaN. Let's try. What we are waiting for? F, let's try minus. Then we multiply and divide 2 NaN. Nice. Divide. Let us try. Infinity divide infinity. Let us plus infinity. Nice. Infinity plus infinity. Infinity. That's good. And any other operation? multiply. I think infinity. Yes, infinity. It's very good. Nice things, guys. So after that, these all I think you got it. So wait a minute. I do have a doubt. We do it like this: minus infinity, and if we multiply it, then okay, minus infinity. Sorry, my mistake. Um, minus. Okay, infinity. Yeah. Okay. Okay. It's good. It's good. If we plus this thing now, what we are going to be have? Minus infinity. Okay. Not bad. Now, nice. And after that, you can see positive infinity is greater than any number. Negative this not equals to this. Nice. But with the help of math, like math module, I have told you. If you don't get, you will be getting them in the future videos when I'm going to explain you the functions. Okay. So after this, we have shortcuts and reliability. These are the some shortcuts you can perform. So if you write x equals to 10, okay, then you have two options. One, you can write it like this: x equals to x plus 5. Then it will change the x value to the next one, and you can do it well like this. And x floor division by 2, this is same as this thing, means x equals to x floor divided by 2. Okay. After that, we have underscores for the million things. You can add underscore at the place of comma. So Python thinks no problem, I don't have any problem. This is a thing of hexadecimal. Okay. If you know something about these binary things, then you get it what this hexadecimal is. But not worry, I'm gonna tell you now what was left, that these int bit length etc things. So same as that. So first of all, there is int bit length, means if we convert integer to binary form, then what is the length of that binary including zeros and ones. Okay. So you can see a binary representation of 10 is 1010. Okay. 1010. Then the output will be 4. Okay. After that, 255 binary form is this lot ones. So output is 8. Okay. After that, bit length. After that, there are bit count. It always tell you how many one. So you can see here that the binary form of 14 is 1110. So when we run and bit count, it gave 3. Okay, because there are 3 ones. Okay. So after that, bit 2 byte int 2 bytes. This does what? It converts the integer to bytes. Okay. So it takes two parameters mainly. Signed is saying when we are saying that we need to take a negative number. If we don't want to take negative number, it's false. Okay. So we said, see, brother, we need length 2, assume that, and byte order we need like big. There are two byte orders, big and small. Yes, I think the small byte order okay, means, I mean little byte order means the smaller byte will come first. What byte? I have told you the combination of zeros and ones is known as byte. Okay, let me do that. So here I'm going to do a byte. So like how many are there? 1, 2, 3, 4, 5, 6, 7, 8. So this is one byte. After that, uh, there is one more. Like wait a minute. 1, 2, 3, 4, 5, 6, 7, 8. There are two bytes. Okay, they can be. The bytes are the number that are from 1 to 250 to 55, I think. Yes. So the number these both, if we convert them to integers, these both can be 1 to 255 numbers. They can be formed in between them 1 to 255. They can be 50, they can be 60, something. I don't know. So what now? There one two this okay 255. Now with the help of hexadecimal numbers, we can convert these bytes. Means the we can show the number from 0 to 250 with the help of hexadecimal two numbers. So when we convert this byte order, it will give us, when we choose learn 2, it will give us like this: 0 x, then some value, like we choose ff, it is 255. Okay, so what these two ff are? Okay, this must be your doubt. What these two ff are? So hexadecimal number can be, hexadecimal numbers are from 1, I mean 0 to what we can say 15, I think. A B C D E F 16 hexadecimal numbers are from here. But at this place, when we go to 10, I mean yes 15, when we go to 10, 10 equals to what? 10 equals to A, I mean capital A. 10, 11 equals to B. 12 equals to I mean equals to C. 13 equals to D. 14 equals to E. And 15 equals to F. So these are all the type of hexadecimal number. And before 10, there are 1 to 9 normal numbers. So these f both represent 15. Okay, means we showed 255 number with the help of double f. Okay, so this is a 255 number, means this is its value is 255. And in the binary form, it, I think it should be 8 ones. Yes, 1 2 3 4 5 6 7 8. So you can see this is 255, and we can represent it like this also. Okay, we can represent this number like this. This number is in hexadecimal and this number is in binary. So the int 2 bytes gave us this hexadecimal number. Okay, so you can see here big little means like some one have 2 bytes, like we need to represent a 255 and 255 double time. This is not, but assume that because I don't have any other numbers. So let see, we need to represent 255 255. Assume that it, not only assume because this will be different, but if we want to represent it, just remove the space. I'm don't gonna to take the byte for space. So just remove that. We are going to use int to byte. A equals to int, I mean 255, 255, 2 bytes. Okay. Dot, what we need to write? Byte. Okay, 2 underscore byte. 2 underscore byte, byte. I think bytes. 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 Now we need to represent. I'm just gonna tell you big. I'm just gonna represent you. Wait a minute. Big. First of all, I just want 2 and big. Now it's good. Control C, Control V. Okay, and I'm gonna tell you here Little. Little. Let's see what we're gonna have. Why? I'm just gonna take you B, and I'm just gonna create a variable over here. NUM, number. Number equals to 255, 255, and I'm gonna replace you by NUM and NUM. Now, would you work? Why? Name big is not defined. Sorry, my mistake. Name little is not defined. Little. I have spelling mistake. Let me check. Is the spelling is correct? I have a lot spelling mistakes. Length byte order. Little. It's good. No problem is there. Why? Int too big to convert. Okay. So if we write 255, gave me a Python. Python Python main main dot py. Wait. Okay. Sorry. I don't print it. Print a comma b. I mean b. So you can see, it gave us this double zero and this double f. First of all, because I written here 2, we can represent these are 2 bytes. This is 1 byte. This is another byte. So we can represent it with the help of single. Okay. So if I write 1 over here, so you can see in the case of big, it gave the, wait a minute. First is a big one is this. I don't even know. I think big is this. Let's check it with 1. So you can see, no, I think big is that one. The double zero is big. So big one gave the big byte first, and small one gives small byte first. Okay. So yes, let me check. It okay. It represent 1 byte. Means there are 2, so it can represent 1 byte. It's there's no problem. You can see stores the big and first. Okay, it store the big value first and store the little value first. Okay, so after that we have 1024. Let us check it. Okay, 1024 need 2 bytes. Okay, see, let's check it by 1024. It say it need 2 bytes, so you can see it need 2 bytes. This is the big 1 byte and this is the small 1 byte. So it gave the big first and small at the second, and this gave the small first, big at the second. Okay, no problem now about the 2 bytes. And if I need to take a minus number, so I just wanted to create signed equals to true. Okay, so you can see it here. Okay, after that there is int from byte. We need to write byte over there. Okay, so we will give it bytes, but don't forget to write b. It's a byte in string. We gave it byte and gave it byte order, and it gave us the correct one. Okay, no need to just see the byte order. Like you can see the byte order is big. Let us try it. See, backslash, okay, sorry, z, and now let me check. Now byte order, if we convert it little, little, then we are going to have 4. Okay, so because we converted the byte order to little, the byte order must be same. Okay, the byte order must be same. Okay, after that, okay, we have done this. Okay, this is, I think, not hard that much. I think you got it. So this much for this video, and in next video we are going to cover tuple, because tuple is small. There are not many methods in tuple. Okay, so we are going to um in next video we are going to do operations on tuple. There are less, not that much. So thanks for watching. Bye bye, we will meet in the next video. And if you haven't subscribed the channel, please click the subscribe button.